My dear students, in this video lesson, we'll be looking into few more theorems from the chapter Circle. No doubt all these theorems were done in the earlier video lessons, but once again I'm revising it so that you understand that this chapter is very important, and please go through these 5 theorems that you need to learn how to prove. Please have a look. Now, Theorem 10.1 has already been done. Theorem 10.2, which is the converse of Theorem 10.1, I've already done in the previous video lesson. Now, 10.3 is a very, very important theorem. This theorem is also done. I have done this in the previous video lesson, and now we will look into Theorem 10.4. Students, these 5 theorems, I want you to learn how to prove them. And I repeat, all these theorems have been intensively done in the earlier video lessons. But I'm revising it once again so that you know how to write down theorems. Okay, now in your forthcoming semester exam, you will be having the chapter on circle. Students, theorems may not be asked, okay, but questions based on them will definitely be asked in the paper. But that should not stop you from not knowing how to write a particular theorem. That is why I am discussing these theorems once again, so that you are well aware of how to write down a theorem. Now please have a look at Theorem 10.4. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So once the statement is given, you have to draw the diagram pertaining to it. So this is an important theorem. And how does the diagram look? A circle with AB as the chord and OM here is bisecting this chord AB. That means AM is equal to BM. I've not shown it out here, but you can draw one line out here showing that AM is equal to BM. Now, what is given? So it is given that segment MA is congruent to segment MB, and what you need to prove that OM is perpendicular to this chord AB. So let us prove it. Take the two triangles OMA and triangle OMB. Now you have to prove the two triangles congruent. So we start off with seg OA is congruent to segment OB because they are the radii of the same circle. So obviously distance OA will be equal to distance OB. So you have to put an equal to sign. Then seg OM congruent to seg OM. So if you look at OM, it is common not only to this triangle but also to this triangle. So OM is a common side, and then you have what is given. MA is congruent to MB. It is already mentioned. Okay, so the 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle. Therefore, the two triangles will be congruent by SSS congruence rule. Students, you have learned the test of congruency in 7th standard. Okay, so triangle OMA is congruent to triangle OMB by SSS congruence rule. Now, after having proved the two triangles congruent, the clue out here is you have to prove OM perpendicular to AB. So that means you have to take an angle. So let us take an angle which is congruent. Now there are many angles which will be congruent. Example, this angle will be congruent to this. This angle will be congruent to this. Likewise, these two angles, that is OMA, will be congruent to OMB. So therefore, OMA is congruent to OMB because of CP/CT. Now, they are the corresponding parts of congruent triangles. But at the same time, these two angles, don't they form angles in a linear pair? Their total is 180 degree. So that is what you will write. But angle OMA plus angle OMB is equal to 180 degree because they are angles in a linear pair. So their sum will be equal to 180 degree. Now let us compare these two statements 1 and 2. I want you to substitute this 1 in 2. You know that OMA is congruent to OMB. So instead of OMA, you could write OMB, or instead of OMB, you can write OMA. So the next step will be OMA plus OMA equal to 180 degree, or twice angle OMA equal to 180 degree. And if 2 times angle OMA is 180 degree, what will be the measure of angle OMA? Yes, it will be 90 degree. So this angle OMA is 90 degree. That means we have proved that OM is perpendicular to AB. So students, this theorem is a converse of theorem 10.3, and this is also another very important theorem that I want you to learn how to prove. Now in the next slide, we will be looking into few questions based on all these theorems. Okay. Now an extra question. You could get such type of questions in your forthcoming exams, that is in your semester exam. If it is an online exam, expect such type of questions. Now in this circle, it is mentioned that OM is perpendicular to chord PQ. And they've given you the value of OM, and the hypotenuse OP is mentioned out here. How do you know it is a hypotenuse OP? Because it is the side opposite to the right angle. Now the question is, you need to calculate the value of PQ. Now let us see how it is to be done. Students, make a note of it, draw this diagram in your notebook and see if you can solve it. And it is based on a theorem, and it is based on theorems that we have completed. So the solution is out here. Look at triangle OMP. It is a right angle triangle. So you will use Pythagoras theorem. So OP square equal to OM square plus PM square. Then you jot down the values. Substitute 5 square equal to 4 square plus PM square. So you get 25 equal to 16 plus PM square. And then you get PM square is equal to 9. 16 goes there, so you subtract and you get the value of PM equal to 3. So PM is 3. Now you know the theorem that the perpendicular from the center of the circle to this chord, what does it do to the chord? It bisects the chord. It cuts the chord into equal parts. That means PM is equal to MQ. So if PM is 3, what will be MQ? MQ will also be 3. So in other words, won't PQ be twice of PM? So PQ is twice of PM. So PQ is equal to 6 centimeter. And this is the reason I have mentioned the theorem here. The perpendicular from the center of the circle to the chord bisects the chord. So you could expect such type of questions in your forthcoming exam, wherein they give you two sides of the triangle. You have to find out the third side, and they tell you to calculate the length of the chord. Let us look into similar type of questions that I have given you. Take a book, make a note of it, and try to solve it on your own. Please have a look. Okay, now there are 3 circles out here. Answer is already given to you, and the question is, in this circle which is in yellow, you have to find out AM, and they've asked you to find out the length of OM. Now understand this figure. Hypotenuse OA is already given to you. The length of the chord AB is 24 centimeter, and OM is perpendicular to AB. So when you look at it, it should strike. Yes, you have done a theorem pertaining to it. The perpendicular from the center of the circle to the chord bisects the chord. So if this entire AB is 24, Wouldn't AM be 12? So AM is 12 and MB is also 12. So here I have mentioned AM equal to 12. Now AM is 12, OA is 13. Can you find out OM? You can find that out by using Pythagoras theorem. So let us calculate the value of OM by Pythagoras theorem. You will get OM as 5. Now let us look into the second question. The circle in gray. MB you have to find out, and you have to find out AB. Hypotenuse OB is already known to you, that is 5. OM is perpendicular to BA and OM is 3. So this becomes a right angle triangle BMO. By Pythagoras theorem, you will use MB. By Pythagoras theorem, you will find out MB. You will get MB as 4. And if you know the value of MB, you can find out the value of MA. MA will also be 4. And AB will be double of MB. So AB will be equal to 8. And because of the perpendicular from the center of the circle to the chord bisects the chord. And now this circle in pink. They have given you here that OM is perpendicular to AB and OA is 17 and this OM is 15. You have to calculate value of AM and AB. So AM is a side of this triangle OMA. Two sides are already known to you. How will you calculate the third side? Yes, you will use Pythagoras theorem and calculate side AM. Answer is given to you here. You should get the value of AM as 8. Try doing it and see whether you're getting it as 8. So once you get this AM as 8, what will be AB? AB will be 8 into 2. So AB will be 16. Because of the same theorem, the perpendicular from the center of the circle to the chord bisects the chord. So students, in all these three diagrams, you're using only one theorem. The perpendicular from the center of the circle to the chord bisects the chord. Now, how do you identify it? How do you know that a particular question is based on this theorem? It's very simple. All you have to do is look for the chord, center of the circle, and there will be a perpendicular drawn to the chord. Center of the circle, chord AB, and perpendicular drawn. Center of the circle, there is a chord AB and a perpendicular is drawn. So when you see a diagram like that, you know that the perpendicular is cutting the chord into equal parts. OM is cutting the chord into two equal parts. Same way here OM is cutting this chord AB into two equal parts. So likewise, if you apply that property, you will be able to calculate the value of the other part of the chord. So I repeat, here AM is 12. So 12, 13, then you can find out the third side OM. And if AM is 12, you know BM will also be 12. By Pythagoras theorem, you will find out BM, then you can find out BA. By Pythagoras theorem, you'll find out MA and then you can find out AB. So students, these are the type of questions that you could expect in the forthcoming online exams pertaining to circle, because such type of questions was not there in the first periodic. So I repeat once again, you could expect such type of questions in your forthcoming online exams. So students, I want you to revise this, go through this very carefully, make a note of it, and learn all those theorems that I have told you is important. Students, in your online exams, theorems may not be asked, but nevertheless, I want you all to learn how to write down those theorems. Okay, it's for your own good. So students, with this, I end my session. And in the next video lesson, we will look into how to prove the opposite angles of a cyclic quadrilateral is 180-degree. And then after that, we will start with lines and angles, because lines and angles will also be a part of the semester exam. Until then, goodbye and take care. Thank you.